All right, here we are, section 2.2, the voiceover to the homework, the algebra of functions. For each pair of functions, find the indicated sum, difference, product, or quotient. So, number one, we're given f of x equal to x minus 6, g of x defined as x plus 3. We're asked to calculate f plus g of 4, f plus g of 4, which by definition becomes f of 4, add g of 4. Alright, so these are fairly straightforward functions here. F of 4 in place of x, I'm going to put 4. 4 minus 6, that's going to be a negative 2 added with g of 4. Let's see. Replacing in a g function, 4 plus 3 more, that's 7. A negative 2 combined with a positive 7 is a positive 5. Alright, and it looks like letter D. Letter D. Number 2 here. We're given f of x defined as 5x squared plus 6. G of x defined as x plus 3, and he's asking us to find f minus g of a negative 4. So this translates to f of a negative 4 subtract g of negative 4. Alright, so negative 4, let's see if I can kind of do this in my head here. Let's see, in place of x, I'm going to put negative 4. Negative 4 times itself would be, well, let me just do it out. 5 times, let's see, negative 4 squared is 16. 5 times 16 would be 80 plus 6 more, that's 86. Alright, now what's g of negative 4? Alright, g of negative 4, this would be, in place of x, I'll substitute negative 4. This comes out to be a negative 1. So now I'm taking f of negative 4, which is 86, subtracting g of negative 4, which is a negative 1. 86 minus a minus 1 would be 86 plus 1, that's going to be 87. And we see 87 right here. It's always nice when we see the right answer. Number 3, if I can put this up a little bit. Number 3, he's asking me to find, well, first of all, he defines f of x as x plus 1, and he defines, nice if you can see it, and he defines the g function as fairly complicated, 5, just by quadratic, 5x squared plus 20x plus 5. And what is he asking me? Fg, which implies times, f times g of negative 3, which translates to f of negative 3 times g of negative 3. What's f of negative 3? In place of x here, I'm going to put in negative 3. Let's see, a negative 3 plus 1 more. Negative 3 plus 1 would be a negative 2 times g of negative 3. Alright, what's g of negative 3? It's a little more complicated. 5 times negative 3 squared plus 20 times negative 3 plus 5. Let's see, negative 3 squared is 9, 5 nines are 45, 20 times a minus 3 is a minus 60, plus 5, 5 and 45, well that's 50, minus 60, this is a negative 10. So g of negative 3 is a negative 10. Minus 2 times a minus 10 is a positive 20. And letter C. Alright, it took a little more time. The g function was a little complicated, not a heck of a lot. Excuse me. Number 4. F of x f of x equal to x squared minus 1. G of x is defined as 8x plus 1. Alright, so what does he want me to find? F divided by g of a negative 1/8. So this is f of a negative 1/8 divided by g of a negative 1/8. There's supposed to be an 8 there. Alright, what's f of a negative 1/8? F of a negative 1/8, in place of x, I'm going to substitute in negative 1/8. So this is negative 1/8 squared minus 1. Negative 1/8 times itself is a positive 1 over 64 minus 1. Let's see, 1 is the same thing as 64 over itself. So this is 1 minus 64 over 64, which is a negative 63 over 64. Alright, negative 63 over 64. And what's g of negative 1/8? G of a negative 1/8. If I can write that properly. So in place of my x value, I'm going to substitute a negative 1/8. So it's 8 times a negative 1/8. Add 1 to that product. 8 times a negative 1/8, the 8s would cancel out. This would be a negative 1 plus 1. Negative 1 plus 1 is 0. So my denominator here looks to be 0. So number 4, anything divided by 0 is what's called undefined. You can't divide by 0. Undefined. I can divide into 0, but I can't divide by 0. Alright, 0 the denominator makes this whole thing undefined. And that's going to be letter A. 4A, undefined. Number 5. Take a little sip of coffee here. Number 5. F of x defined as x squared minus 1. G of x defined as 2x plus 1. He's asking me to calculate f divided by g of a radical 6. So, in place of the f function, I'm going to substitute in place of the x, I'm going to substitute in radical 6. So this is, let's see, this would be radical 6 squared minus 1. Radical 6 times itself is just 6 minus 1. That difference is 5. There's my numerator, 5. And what about g of this radical 6? G of radical 6. So in place of x, I'm going to substitute in radical 6. So this is going to be 2 radical 6 plus 1, which is just that, 2 radical 6 plus 1. So in my denominator here, I've got 2 radical 6 plus 1. So this is what I've got here so far. 5 over 2 radical 6 plus 1. Now, you're not going to see this answer here now. This is unusual because what you've got is this radical in the denominator, which radicals in the denominator are not allowed. Now, I may cover this in a separate video because you don't see this answer listed here, all right? If you look at all the answers, all of them have whole numbers. What you've got to do is to solve this, you've got to multiply. Now, whether or not you see this on an exam, probably not. I'll handle this in a separate video. You need to rationalize this. And how you rationalize this is to multiply both numerator and denominator. If this is 2 radical 6 plus 1, I'm going to multiply this by 2 radical 6 minus 1, both in the numerator and in the denominator. Alright, now what ends up happening is 2 times 2. That becomes 4. Radical 6 times itself is 6. The middle term will cancel out. That's why I'm changing the sign here. Alright, so a negative 2 radical 6 and a positive 2 radical 6 will cancel out. And then finally a positive 1 times a negative 1 is a negative 1. So my denominator is 24, subtract 1, 23. As I look at this number 5, the only one that has a denominator of 23 is letter A. Now why is the numerator that? Well, 5 times 2 radical 6 is 10 radical 6, and 5 times a negative 1 is a negative 5. Alright, so you see exactly. It's called rationalizing. Alright, 2 radical 6 plus 1. The conjugate of that is 2 radical 6 minus 1. The reason you're changing signs is you want your middle term with the radicals to cancel out, giving you a nice whole number. Alright, I'll talk about that separately because that's kind of an unusual one. In class, number 5 always raises questions because of that rationalization. Alright, number 6. Move this just a little bit up. Number 6, what do we got here? F of x equal to x plus 3, g of x equal to radical x minus 7. And he wants me to calculate f minus g of a negative 3. Alright, so this simplifies, or by definition, this translates to f of minus 3 minus g of negative 3. F of minus 3. So in the f function, replacing x with minus 3, of minus 3 plus 3, that'll be 0 minus g of minus 3. If I put a minus 3 here, this is interesting. Alright, if I calculate g of minus 3 in place of x, I want to put minus 3 minus 7. This is the square root of a negative 10. Well, the square of a negative number is something that's imaginary. Alright, so in our work, this doesn't exist. So if this doesn't exist, 0 minus something that doesn't exist, DE, gives me an answer that doesn't exist. And the reason being is that your radicand, the value under the radical, is negative. This is an imaginary number, which we'll study in a couple of sections. So number 6, letter B, does not exist, only because this radicand, the thing under the radical symbol, was a negative value. Number 7, if I can write it. H of x, not f of x, it's h of x, number 7. H of x, f of x, they're just using a different letter to describe the function. It could be called any letter, actually. H of x is equal to x minus 1. G of x defined as radical x plus 9. He's asking me to find hg of negative 4. Alright, this implies multiplication, h times g. Alright, so this simplifies, or by definition, this is h. Here again, I like writing those f's, don't I? This is h of negative 4 times g of negative 4. H of negative 4, if I replace x with negative 4 minus 1, what's negative 5? That's easy enough. Replacing a negative 4 into the g function, negative 4 plus 9, that'll be 5. So this will be times the square root of 5. Alright, negative 4 plus 9 is 5, square root. And then multiplying those two together. Number 7, you're going to get a negative 5 times radical 5. Negative 5 times radical 5. Number 7, the letter B. Alright, so the first 7 were pretty much finding composite functions. Not composite, but adding, subtracting, multiplying, dividing when they give us a value. And from 8 on, well, 8 until we get to the difference quotient, we're not finding a specific value. He just wants me to either subtract, add, multiply, divide the functions. So it's just a bunch of algebra. Not hard at all. Number 8. F of x defined as 5x minus 4. G of x defined as 3x minus 5. And what is he asking me to do here? He's asking me to find f minus g of x, which simplifies to f of x minus the g of x function. All right, there's no value. He just wants me to take the two functions and subtract them. All right, so what's the f of x function? It's 5x minus 4 minus, and in parenthesis, the g function, 3x minus 5. So this is 5x minus 4. This minus sign that precedes the parenthesis changes the signs of the terms within the parenthesis. A minus times a minus is a positive, and then combining like terms, 5x and 3x combined is 2x. A minus 4 combined with a positive 5 is a positive 1. 2x plus 1, letter D. Number 8, letter D. There it is right there. 2x plus 1. All right. Let me flip to the next page. Number 9. F of x defined as 9x squared, minus 7x, g of x, x squared minus 3x minus 28. And what is he asking me to find? F divided by g of x, which by definition is f of x over g of x. F of x is that bad boy here, 9x squared minus 7x. And in your denominator, you get your g function, which is x squared minus 3x minus 28. All right, so number 9, it's pretty straightforward. There's nothing to do here. Only thing I could say could happen down the road is that maybe, you know, when you factor this and you factor the denominator, the numerator, it could have been a like set of terms that canceled out. But in this case, it did not. So he wouldn't give you this and then give you an answer that was in simplified form. So we're all set. Number 9C. He's not going to be that grimy. At least not yet. Number 10. F of x defined as 8 minus 6x. G of x defined as a negative 3x plus 6. And what is he looking for? F plus g of x. By definition, this is f of x add g of x. Here's my f of x. It's 8 minus 6x, add to that g of x, which is a minus 3x, plus 6, let's see, 8 minus 6x, plus or minus is a minus, this is an x, not a 64. Looks like a 64, doesn't it? A plus or minus is a minus. Alright, combining your x's, minus 6 and a minus 3, that's going to be a minus 9x. 8 plus 6 more, well, that's 14. So minus 9x plus 14, and letter D is looking really good. Minus 9x plus 14, you see it right here. Number 10, letter D. Number 11. F of x. Give it to me as the radical 3x plus 4. G of x defined as radical 9x minus 16. What's he looking for? F g of x. Recall, there's no symbol in there. It means times. So this is by definition equal to f of x times g of x. So what are we doing? We're taking this guy, multiplying it times that guy. Alright, this is number 11. And I think I see it right here. Alright, number 11. Here it is. There's my f of x, right, times my g of x. Right, it's all. There's no simplification here. Right, just pretty straightforward. Just the way you see it. F of x times g of x. I don't know where they're getting these other crazy answers from. 11 is straight out B, and you're all done. Number 12. F of x defined as 4x minus 9, and g of x given to us as 6x plus 4. And what's he looking for? Once again, he wants the product of these two. He's looking for f times g of x, which translates to f of x times g of x. Well, here's f of x times g of x. And our old friend foiling. Alright, to multiply these two binomials, you've got to FOIL. Alright, product of the first terms, 4x times 6x, that's 24x squared. Outside terms, that's going to be a positive 16x. Inside terms, a minus 54x. And my last terms, a minus 9 times a positive 4 is a negative 36. Combining like terms, 24x squared, let's see, a positive 16, and a negative 54 is a negative 38x minus 36. And that's looking a heck of a lot like letter D here, 24x squared. Minus 38x minus 36. And the key thing is, you get two binomials, you got to FOIL them. Product of the first, outside, inside, outside, and last terms. Number 13. F of x given to us as 4x minus 3. And g of x defined as 7x minus 4, and what does he want? The quotient again. F of x divided by, I'm sorry, let me just, first of all, he wanted this. F divided by g of x. So that's f of x divided by g of x. Alright. This is the quotient here, number 13, quotient. So f of x is 4x minus 3, g of x is 7x minus 4, and that's all there is to it. There's no simplification possible. No like terms in the numerator and denominator, so pretty straight out. Alright, 13, there it is, letter A. Right there, nothing much to it. Number 14 is a little bit different. The first time we've seen something where we're using the product of the same function. Let's see, f of x defined as 5 over x minus 2. Now, what is he looking for? He's looking for ff of x, which implies f of x times itself. Alright, ff of x. F of x times itself, f of x. So what do we got here? 5 over x minus 2 times itself, 5 over x minus 2. 5 times 5, well, that's 25. And here again, you got to FOIL this out here. X minus 2 times x minus 2. X times x is x squared. A minus 2x combined with another minus 2x is a minus 4x. A minus times a minus is a positive 4. So 25 over, well, in fact, what he did here in number 14, he didn't even force us to do the FOILing here. He just said x minus 2 times x minus 2 is x minus 2 quantity squared. Alright? He didn't even bother multiplying. X minus 2 times x minus 2 is x minus 2 quantity squared. He made that one real easy for us. He didn't even force us to FOIL. I say he. Could very well be a she. I don't want to be sexist. Alright, so that was number 14. And let's see. Moving right along here. 15. 15. F of x defined as 2 over x minus 2. And g of x defined as 1 over 4 plus x. And he's looking for, once again, a lot of division here. F divided by g of x, which translates to f of x function divided by the g of x function. So what do we got here? The f of x function is 2 over x minus 2 divided by 1 over 4 plus x. Now I know when I divide, I multiply by the reciprocal. So this is 2 over x minus 2 times. The reciprocal of that is 4 plus x over 2. And apparently he wants me to do some multiplication here, but what number is this? This is number 15. And when I used the reciprocal of this, yeah, did a good job, Mr. Gomes. Can't read my own writing. The reciprocal of 1 over 4 plus x is 4 plus x over 1. And that's a lot better. Why making my problem harder for myself? So what do we got here? We got 2 times this guy, 2 times 4 plus x, product of the numerators. X minus 2 times 1 is simply x minus 2. He doesn't even take the time here to do the distributive property, right? He just gives it to me just the way it is. Letter B, number 15, all right? There it is, 2 times that, and then the numerator. My mistake was, that's a 1. I wrote a 2 initially. Anyway. Okay, so that's the first part. Now these second ones are all, let's see this, 16, 17, 18, and 19. Some of these are going to take some time. Not the first 2, but the last 2 are going to take some time to do, but maybe we'll worry about that when we get there. Alright. So, he defines the difference quotient for us. Alright. We saw this way back when, and I told you that we would have some problems dealing with this. Alright, so f of x in number 16 is defined as 9x plus 6. Alright, so we need to solve this difference quotient. We need to calculate f of x plus h, subtract whatever f of x is, and divide that by h. So the first thing is finding f of x plus h. So f of x plus h, wherever I see x, I need to substitute x plus h into this function. So this is 9 times, in place of x, I'm putting x plus h, and then I'm adding 6. So distributing, I get 9x plus 9h plus 6. Alright, so this first part here is 9x plus 9h plus 6. Now I have to subtract f of x. Subtract f of x, which is 9x plus 6, and then divide this whole thing by h. Alright, so simplifying, this takes some time. This is 9x plus 9h plus 6. The minus sign preceding that bracket or parenthesis changes the signs. It becomes a negative 9x. A minus times a positive is a negative. All of this divided by h. Now what happens in all these problems, you get nice cancellation. The x's cancel out, the positive and the negative 6 cancel out, leaving me simply what's remaining in that numerator, 9h divided by h, and of course the h's would cancel. You know you've done this right because the answer will simplify down to something really simplistic. So all of this mess is just simplified just to the number 9, letter A. Just gotta go slow. And don't make any silly errors like calling a 1 a 2. 17. F of x defined as 5x minus 8, excuse me. So here's my difference quotient. It's f of x plus h minus f of x all over h. This is the hard part right here, finding f of x plus h. So in place of x, I'm going to substitute x plus h. So this is 5 times. In place of x, I'm substituting x plus h, then subtracting 8. So this is 5x plus 5h minus 8. So that's what this guy is here. So 5x plus 5h minus 8 minus f of x minus all this. Well, minus this is going to change both the signs, all right? I can write it out, so I'll put it in parentheses rather than a bracket. And this whole thing is divided by h. So simplifying, 5x plus 5h minus 8, the minus sign preceding the parentheses changes the signs of both those terms from what they were to the opposite. The plus becomes a minus, the minus becomes a plus. This is divided by h. And once again, cancellation happens. You know you're right because you're going to get nice cancellation, which is kind of neat. 5, leaving me a numerator of 5h over h. H's cancel out. A nice whole number of 5. 17, letter A. That's pretty sweet. Alright. Now, the ones that require the most time and the most effort are given to us in the last two. And the reason they require more time and more effort is that if you look at both the functions, coffee went down the wrong pipe. Both of these guys have squares. Alright, so what we're going to need to do is in place of x, we're going to be substituting x plus h and so forth. But in squaring it, I'm going to tell you right now, well, let me just kind of figure this out. Here's my f of x. 7x squared plus 8x. Now, my difference quotient, tells me to find f of x plus h minus f of x and divide that by h. So f of x plus h, wherever I see x in this function here, I got to replace x plus h. So 7 times x plus h, I got to square that, plus 8 times x plus h. So here I got to FOIL this out, all right? And you should write this in your notes because you're going to see this at least once. We use FOIL x plus h. X times x is x squared. You get an xh and another xh. H times h is h squared. One of these xh's plus another xh is 2 of them. So this guy FOILed is x squared plus 2xh plus h squared. Please write this in your notes. Saves you the time of having to FOIL every time you see it. Plus 8 times x is 8x. Plus 8 times h is 8h. Here again, I'm just working on this. I haven't even got to this part yet. I'm still working here. Distributing, I've got 7x squared plus 14xh plus 7h squared. I'm taking the 7 and multiplying it times everything in the parentheses. Plus, let's see, plus 8x plus 8h. Wow, it's a long thing. Now, that was just that. Now I need to subtract f of x. Well, here's my f of x. If I subtract this, I'm going to have a minus sign out in front of 7x squared plus 8x. It's going to change the signs of both those terms. This is going to be a minus 7x x squared, a minus times a positive is a minus 8x. Now I realize this is all over h. Now, if I've done this properly, I'm going to get cancellation. 7x squared cancels out with a minus 7x squared. 8x cancels out with a minus 8x. And that looks to be all that's going to cancel out. So what have I got here? 14xh plus 7h squared. So I've got this, I've got that, and what's left here is a positive 8h all over. Now I know I'm on the right track because if I've done this properly, there should be a common factor of h in all three terms here. Factoring this out, this is 14x plus 7h plus 8 all over h, and the h's cancel out. So number 19 here, what do we got? 19, 14x plus 7h plus h, 14x plus 7h plus 8, there it is, letter A. You know, it's just, we have these square terms, it just requires a lot of algebra, alright, but if you've done it correctly, things should simplify to the most three terms when you do the final cancellation. Alright, so I have enough room? Probably not. So let me write 19 on a separate piece of paper here. F of x is defined as 2x squared plus 4x. So we need to find f of x plus h minus f of x, all this divided by h. So f of x plus h. So wherever I see x, I'm going to substitute in this f function, x plus h. I'm going to square that and multiply it by 4. Now I've already shown you what this guy looks like foiled out. This is x squared plus 2xh plus h squared. Please don't just try to square the first and the second term. You got to foil this. An xh and another xh is two of these xh's. Plus, let's see, 4 times x is 4x, 4 times h is 4h. And distributing, we get 2x squared, 2 times 2 is 4xh, 2 times h squared, 2h squared, plus 4x plus 4h. Wow. Now I need to subtract f of x. Alright, so if I'm going to subtract this, alright, if I'm going to subtract this, what's going to happen is both the signs are going to change of these two terms. It's going to be a negative 2x squared and a minus 4x. A minus times a positive is a minus times a positive is a minus. All of this divided by h, and if I've done this right, I should get some nice cancellation. 2x squared goes out with a minus 2x squared. Minus 4x cancels out with a positive 4x, leaving me 4xh plus 2h squared plus 4h. Alright, let's make this plus that all over h. Wish I could draw a nice straight line, but apparently I can't. Now, if I've done this right, I should have a factor of h in the numerator in all three terms. I'm going to lipo that out. This is 4x plus 2h plus 4 all over h, and then my last step is to cancel the two h's. Alright, 4x plus 2h plus 4 sure looks like letter C to me. Alright, 4x plus 2h plus 4, 4x plus 2h plus 4. It's always nice when you see the right answer there, letter C. Alright, those took some time, but it's college. Hope that helps you.